Hi everyone, and welcome to the second video of the Flutter Animations course. In the previous video, as you saw, we talked quite a lot about trigonometry, and we also looked at animation controller, animation, tween, and we also looked at animated builder and transform. And we created quite a simple animation in the previous video, and in this video we're going to build on top of what we've learned in the previous chapter, and also I think during the introduction mainly of the previous chapter where we talked about trigonometry. We're going to create a little bit more advanced animation. I'll show you how this animation looks like, what we're trying to achieve. I'll bring it up here. Try to zoom into it a little bit, and you can see it's basically two half circles that are rotating around which axis? They're rotating around, this will be actually difficult to see right now, but they're rotating around the Z axis, of course, because it's rotating counterclockwise around the center. That is the Z axis, right? And also they're rotating around what seems like first, like this is the Y axis and then the X axis. So you would probably think that, oh, there are three animations. Don't worry if this is a little bit complicated right now, but I'll explain it. This is actually just two simple animations connected to each other, okay? And there's no X and Y animation. It's simply a Y animation flipping on its head. I will explain how this is working, and I just wanted to tell you that when it comes to animations in any front-end framework, it doesn't just have to be Flutter, or it could be Swift UI, it could be Jetpack Compose, wherever you're working with animations. The important, at first, I'll get rid of this animation. The important thing to remember is that the most significant phase of creating the animation is breaking it down into smaller steps. So it's not just creating the animation, but it's just to be able to conceptually understand what phases that animation has. All right, so sometimes when I'm trying to create an animation, I stare at it for about 15 minutes. So if someone creates Adobe XD or they give me some animation and they say, can you do this in Flutter? I just stare at the animation just like a crazy person for a long time. And that's simply because I'm trying to break it down using the tools that we have in Flutter, for instance, transform, stack, as we'll talk about it soon, actually, not in this video. I think in the next video, we'll talk about stack and its importance in creating animations in Flutter. But you need to know the tools that you have, and then you need to understand how those tools that you have are going to come in handy when you need to create an animation. So breaking down the entire animation into small steps and then delivering on those steps. So when someone looks at an animation, they think, oh my God, how did they create this animation? It's magical. But most of the times it's just a series of small phases connected to each other. Okay, as is this particular animation, okay, which we had a look at just now. So it's just two animations connected to each other. All right. So without further ado, let me just start creating. Actually, we could start creating the projects. I'll bring up the terminal in here. Okay. So let's say I'll increase this a little bit. So I'm going to go here and say Flutter create example2, and I'm going to say org is se.pixelity like this. So you don't have to, and you shouldn't probably specify the org as I did, because that's my reverse domain name. So you probably want to specify your own reverse domain name. So let's go to example2 in here. And we do the normal dance in here. I'm going to say workspace settings, zoom level, which is 5. And we don't have any third-party libraries in our animations, but I'm going to go to main Dart and add my FSA, which is Flutter Scaffold application, which I explained in the previous example. Let's say select device in here. I'm going to say iPhone 14 Pro, and then let's see if we can run our application on that. Okay, so as soon as we run this application on example2, unfortunately, we're not going to be able to see the previous one. Okay, but just keep this in mind, how this animation looked like. I can always run the previous example, to be honest with you, so that's not a problem. So we can always bring up you can see all the examples that we're going to do, but example2, unfortunately, is going to be overwritten by this one. And now that I'm thinking about it, maybe it's actually a good idea to keep example2 alive like the way it was, because right now what I did is that I ran this code example2 on this iPhone 14 Pro Max, and then we can't see the previous example, or not the previous example, but the actual animation that we're going to develop, because this new application overrode the previous application. So I have a solution for that. So what I'm going to do, I'm going to stop this. I mean, you don't have to do any of this, but I'm going to bring up the example code. I'm going to run that on this simulator. And at the same time, I'm going to go and open a new one. And I'm going to say open an iPhone 14 Pro. And so this is going to be what we're going to develop. And on the left-hand side, we're going to have our current application and see how it progresses into creating this animation on the right-hand side. Okay, so I'm going to go here in this code and say it's iPhone 14 Pro instead of the Pro Max. So this one is going to be the model that we're going to develop, and this one is going to be the current application. All right, so let's see how things progress. While these are doing their build, so actually this is finished now, I can see. So this is our model. I'll get rid of it here. And this is going to soon finish as well. So while these are ongoing and happening, I think we need to go into explaining the basics of how we need to achieve this. So there are so many different parts to this animation. I think we need to break them down. All right. So as usual, I'll just bring my iPad screen so you can see when I write on the screen. Here we go. Okay, so that's that. Then I will go ahead and start drawing the different phases of this animation for you. Okay, so the first thing that you need to understand when it comes to animations is, as I said, it is made out of smaller steps. So you have to break this down. And the first thing you need to break down is, how is this guy even drawn on the screen? Like, what is the components that are making up this animation? All right, so the first thing you need to look at is the shape. All right, how is the shape created? You can see two half circles. So then the question is, how do we draw two half circles, or half circles for that matter? Okay, so you could say, okay, well, half circles are easy to do. You just take one widget and you break it into two. But how do you do that? How do you break a widget into two? Well, there is an interesting widget in Flutter, which is called row. Okay, so if you could place your components inside a row, that would be really good. So let's just draw a row in here. I'm gonna do some reshuffling a little bit on the screen. Okay, so let's say that you have a row. Good. This is your row, and then you divide it into two parts. So what would be really good is if you could then draw two half circles in this row. So the left part, which is, let's say this is a container equal to 100 points in height, width, and 100 points in height. Same thing in here. Okay, so something like this. All right, so let's say that these are two containers placed inside a row. So this is a row. Okay, and this is container 1, cont 1, and cont 2. And let's say that that we want to draw two half circles. So on the left hand side, if you look in this component right here, let's say that we want to draw a half circle, which we assign to the left hand side. So what do we have to do? If you then take your mouse, or how do you say, take the pointer of drawing to this point, to the farther rightmost that you can go, and the Y position, because remember, the canvas in Flutter goes like this, X, and it goes like this in Y. Just keep that in mind, so that we don't have to repeat that fact over and over again. Okay, so keep that in mind. So given that fact, in this example, in this container, if we take the pointer, go from, so this point 0 and 0, and say go to the width for the X part, go to the entire width, which is 100. Okay, here with the Y position of 0. So take the width and the height position of 0, move the pointer there, and then draw an arc from that point to this point down here. Okay, and the radius of this arc should be half the width. So this is half the width, which is a radius. Okay, so this is 50. So if you say take this point, go from this point, and draw an arc counterclockwise from point 1 to point 2, then you end up with this half a circle. Okay, so there are some methods in Flutter that you can take advantage of to draw these arcs. So you specify the radius, you say if it's clockwise or counterclockwise, and then you say from which offset to which offset it should draw the arc for you. Okay, and it doesn't necessarily have to be this kind of arc, like this is a perfect half circle, but an arc could be like to say that you have a point in here and a point in here, and your radius is like 10, which is right here, then it would draw an arc that looks like this. So it doesn't have to be half a circle. Sorry, it doesn't have to be a perfect half circle, if you know what I mean. Okay, so let's go back to this node that we were drawing. So that's one thing. So that's the left-hand side of the animation or the shape. Now, the right-hand side would be to say, okay, we're working now with this container in here. Okay, so given that container, let's stay at this point. Let's stay at the top left point, which is the default point. Then what we want to do, we want to take the radius, again, it's 100 divided by 2, okay, which is in the middle. And we go from this point, which is right here, and to this point, which is right down here. So we want to draw an arc with the radius of 50 from that point up there to this point down here. And we say, okay, start doing this, but do it clockwise this time. Because remember, if you say from this point to this point down here, counterclockwise, with that radius, it will draw a line back here where this component doesn't even exist. Remember, this component takes this space in here, okay? So you want to draw your arc on the right-hand side of the circle clockwise. So it will then go like this, all right? So we've now broken down the component that we're going to draw on the screen. So we need a row with 2 containers. Why don't we just do that? Why don't we just create a row with 2 containers in it? Okay, and we'll specify a width and height and colors for it so that it will start already looking good. All right, and then we can make sure that that row's components are in the center of the row. Okay, because otherwise your row, like this, if this is your screen, then your row's components will probably just be here depending on their width and height. We kind of want it to be in the center, okay? Because if you remember our animation, I'll bring it up. Let's see where it is. Here, it's in the center, horizontally, all right? So let's not complicate the animation at the moment more than it has to be and start actually creating these 2 components, all right? Let's go back to our code, and I'm gonna get rid of some stuff on the screen. Let's get rid of our app bar here. And then I'm going to say the body of our scaffold is a, how should we say it? Should we just say it's a row? Perhaps, yeah. Let's say it's a row. And we say its main axis alignment is center. All right. And we say it has children, and we just create 2 containers, basically. All right. So let's say we have a container. Let's say container. And I'm going to say it has a color. And we say colors.blue, and we say it has a width of 200 and a height of 200, like this. And then I will create another container, because remember, in the beginning of that animation, the blue container is on the left hand side. It's difficult to see it because we have to restart the animation, but to begin with, the blue part is on the left hand side and the yellow part is on the right hand side. Okay, it doesn't really matter the colors, but I just want to create the exact same animation. All right, so blue part on the left, and then we say the second container has yellow, and then it has the width and height of 200 as well. I can see that here we have some problems, and because we're running on a smaller screen, so it is looking like this, as you can see. All right, so let's just change this, and we need to perhaps say that it is 100 by 100. I mean, it doesn't really matter, but 100 by 100 also works. Oh, did I just change it to 200 again? Like this. All right, so this is, I would say this is fine, right? And it would be really good if you could put this in some sort of a safe area so it doesn't take this dynamic island and draws on top of it or under it. So let's say that the row is behind a safe area. Let's see if we have safe area here. No, safe area. Boom. Good. So you see the colors don't match. So let's just change those colors. So let's say colors.blue. And for the blue color, I'm going to take 0x, let's just say color, const, color 0x, FF0057. Where am I typing? Here, 57B7. Oh my God, 57 and B7. All right. So the blue matches, and let's just go to the yellow and say colors. Sorry, const color, and let's say x0x, and we say FFFD700. Actually, I think it is right, or 4Fs, I think it should be. All right, so now colors match. So we have the exact same blue color, I think. The blue color still doesn't really look exactly the same. 57B7, that's fine. Yeah, it is probably the same. It's just my eyes, because this one's a little bit bigger. Okay, so you see, this is the first step. I know it's baby steps, but it is still important to understand that animations don't happen just like that. You need to break it down. You need to make one step, like you should progress one step at a time. All right. So what is the next natural step? Well, we have to clip these guys. We should say that this is a container with a width and height of 100, but we want to clip it. Okay, so the clippers are a very important part of animations. So what we want to do is to say that, hey, we have a container, and let me get rid of this annoying animation. We have a container, but we kind of don't want a part of it. And that is like on the left hand side, we don't want this left hand part. And on the right hand side, we don't want the right hand part either. So let me draw something on the screen so you see what I mean. Now let's go back to our iPad screen here. I'm gonna get rid of this note, delete it. And we could delete this node as well here. And let's create a new node. So let's say that this is one of our containers on the left hand side. Okay, so at the moment it is completely filled. All right, so it is filled with a color, and it is, was it the yellow one? No, I think it was the blue one on the left hand side. Okay, so let's say this is the blue container, and we want to draw basically from here to here and like this. All right, so this is the center of that container. So what is happening is that we've colored this entire container, but what we want is to clip this part out. So this part that I'm drawing on at the moment should be clipped out of the picture. Okay, so in order to do that, we need to use clippers. And there is a component that does this in Flutter, and it's called clip path, right? So the important thing to understand about clip path is that you specify the shape that you want to hold on to. So you want to basically let's go back. I'm going to delete this and let's go here. So you want to keep this part that is here on the left hand side, but you don't want to keep this part. Okay. So with clippers, your job is to define the shape for what you want to keep, which is this guy right here. Okay, so don't think that, oh, it's a clipper, so I have to clip out something. So I'm gonna clip out this thing. Okay, that's not how it works. So you need to clip, you need to ensure that you're keeping onto this component right here. Okay, so I'm gonna show you how that code is gonna look like. And if it's the first time that you're working with clippers, it could be a little bit maybe difficult to understand them to begin with, but I think we need to break that part down as well. So what I'm going to do is to create a little enum in here. So let's just say we have an enum. So let's define the two parts of the circle. We say the left part and the right part. So let's say circle side, and we say left and right. All right. So now given the circle side, let's go ahead and create a path using which we define the part of the circle. So the left part has this thing, right? And the right part, has that other thing, which is on the right hand side. We've already talked about it. That's why I don't explain it so much. All right. So let's say we create an extension on, and we call it to path on circle side like this. And we want to create a path. All right. A path object. Don't worry. I'll explain it all. So let's say path, and we say to path, and we give it a size as well, because it is important that we specify the size to this function, because otherwise this function doesn't know the size of the container that it has to clip to. All right. So don't worry about it. Let's just create a path in here. We just say, let's say var path is a path like this. All right. And then we need an offset basically a point to start our drawing from. So in this case, we say the drawing has to start from this point up here, and it has to end up at this point down here, and it should draw an arc counterclockwise. Okay, so let's say we say an offset, we have an offset parameter in here, not parameter, but variable, and we say also a Boolean that should say whether it's clockwise. Okay, then we switch, we say switch self like this, or sorry, not self, this. And let's add the missing cases in here. So, all right, let's start with the left-hand side. So for the left-hand side, what we want to do is to say that in this path, the pencil, remember in every path, there is a pencil that is like you literally drawing on the screen. The pencil should first move to this point. What is this point? I mean, where does it exist? Remember, the x-axis is here, the y-axis is here. This point's x coordinates is the width of this container. Where do we get the width from? It is the offsets. It's in the size. Okay, so let's say that path move to the x coordinates is the size's width. And what is the y? Well, the y is basically nowhere. It's in 0. Y hasn't even gone down. We're right here. Okay, so the y is 0. Okay, so we say, okay, we've moved the pencil there. Now we want to basically say where we want to move to. It is down here. What is the coordinates for this guy? Remember, the origin is here. So here is literally its x coordinate is equal to the width, because we've gone all the way from the left to the right, it's equal to the width, and the y coordinate is the entire height. Okay, so we say we want to move, the offset is, let's say size width and size height. Okay, and then we say, is this clockwise? No, because it has to move from this point here like this, so it is counterclockwise. Remember, clockwise goes like this. Okay, it is like a clock. So this is counterclockwise. It's going the opposite way. So we say clockwise is false. All right, so we've calculated that part. Let's do the same thing for the right-hand side. And let me just draw a little bit on the screen for how the right-hand side looks. So I'm going to move around here a little bit on my chair to bring up the iPad screen. So let's just delete this node. Actually, maybe I shouldn't delete this node. Maybe I should create a new one, okay? So let's say the right-hand side, which is this container, we need to ensure that we start from this point. So I say start, and in here we say end, okay? And then the center or the radius is gonna be half the width. So this is our radius, and we're gonna draw an arc clockwise through that. Okay, so we say start from this point, which is 0, 0. Okay, this is 0 and 0. And this point end is what? 0. And its y position, it has gone all the way down to the height. So it's equal to 0 and height. That's our offset. And the radius is half the width. Okay, because if this thing is the width, radius is width divided by 2. And width, usually in case of circles, we're basically talking about diameter. So this is either width or your diameter. Okay, width or diameter. Maybe I should actually remove that because mathematically that doesn't look so good. How do we erase here? I wish I had my, okay, somehow here, eraser, boop, 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 like that. Okay, so now we have this. So let's start actually defining these variables. So I'm gonna go here, and let me put my pen back also on my iPad. It makes a little bit of a clicking sound, so I just want to avoid that. So the path, we just say, do we have to move anywhere, by the way? No, because the pencil on a normal canvas or in a normal path in Flutter by default is in 0, 0. So you don't have to move it in this case when you're drawing the right-hand side of the circle. So let's say we don't have to do move to, but we say offset is equal to, we want to move here. Remember the x coordinate is 0 and the y coordinate is the height. So we say is an offset equal to 0 and size height. All right. And then we say, well, the arc should be drawn using a clockwise motion. So let's say clockwise is equal to true, like that. All right. Now that we've done that, what we need to do is to draw an arc. So we say path arc 2 point. Okay, you can see it has some parameters and it says arc end, which is your offset. then let's just say move to this offset. Then it has a parameter for radius. It says, okay, what is the radius? And we say it is a radius. It's a elliptical, all right? And it says, okay, what is the width, sorry, where is the center of your circle using which I need to derive the radius. Then we say, okay, you need to create this center at width divided by 2 and height divided by 2. Remember? Okay, so I think that part you understand. I have to explain it. Okay, so the center, we're specifying the center. So we say size width divided by 2 and size dot height divided by 2. Okay, so we specified the center. Okay, and basically using this center, Flutter will understand the radius. Then we say clockwise is the clockwise parameter. All right, so now we've defined that path. So now that you've done that, you need to also close your path. All right, because if you don't close your path, the pencil is here, but it doesn't understand that it has to go all the way to the top to close the path. So a lot of students actually have problem understanding how path close works. And the way it works is very simple. So let's just say I draw a smaller container here. So what we did is to say, okay, go here and take the center and take this endpoint, draw an arc here. But okay, how about this line down here? Let me actually undo this somehow. Let me bring up my eraser and basically clean this. So this is what we have specified at the moment to Flutter. Literally, we said that go from the top left to the bottom right, but then we didn't close the path. So there is a function on path that is called close, which specifies that, okay, you've done this line now here, now close it. So go from where the pen is right now, which is, we left the pen right there. Remember, we took basically the circle. We went like, sorry, half the circle. We went like this. So there's where the pen is at the moment. Then we need to tell it to close this path like this. Okay, it looks like a car flipped on its head. So that's what close means. We need to close that path in order to ensure that we've actually created a complete path. Otherwise the path isn't complete. All right, so let's go in here and say that the path needs to be closed now. So we say path close, and then we say return path like this. So we return it. Also, I noticed that we created a var in here. I wonder if we should say it's a final, because we're not actually changing the value of that path. We're only mutating it internally. Okay, so now we have that part. Okay, how do we apply this guy now to our containers? Well, you need to create some sort of a widget that turns this path to life, right? We're creating a path object, but path isn't a widget, okay? So somehow we need to turn it into a widget. So how do we do that? Well, there is a trick to doing that, and you need to create something called a custom clipper. Okay, so let's go ahead and create a widget in here, and we're going to call it half circle clipper. Okay, so I'm going to say that this is, let's just say, class half circle clipper, and we should say it extends custom clipper, and it's the custom clipper of path. All right, so in here we need so this is a widget. Remember, custom clipper is actually a widget. So if you go to, let's see if you can find it, listenable, add listener. No, wait a minute. Actually, sorry about that. I'm sorry about that. The custom clipper is actually not a widget. We're going to place this inside a widget. Okay. Custom clipper is going to go into a widget. And I think actually that widget was called clip path. All right. And clip path requires a custom clipper. So first we define our path, then we place it inside a custom clipper, and then we put this custom clipper inside a widget, which I think was called clip path or something like that. We'll find it out, don't worry. But this guy's job right now is just to embed this path into itself. All right, so let's go ahead and program this guy. So there are a few functions that we have to implement. So let's just get help from Visual Studio Code and say 2 missing overrides. Okay. You can see that it says, give me the clip, and we say, okay, it requires a path, and we know that we have the path in here, but in order to get this path, we need a circle side. So let's get a circle side first into this. So we say final circle side is a side, and then we create a constructor for this guy like this. All right, and we say that it is a required like this, Okay, I'm not sure if we can create this a const actually. Seems like we can. Good. So now that we have that in this guy, in the path, let's just say that we say side to path and we pass the size to it. You see how easily it plugs and plays? A lot of people also prefer to have like this code, the path creation right here. Okay, I just thought so that we can separate every bit of the code into smaller bits so we don't get confused how things are working together. But if you feel like it is better for you to move this code, which is here, down there into this function, be my guest. Just do that if you want to. Okay, then we have to implement this function. A lot of people also get confused about this function. So how this guy works is that it tells you of changes that are happening to the parent widget, and it says something happened. Do you want to redraw your path? All right. And in this case, we're just going to make our lives easier and say, yeah, whenever you say something has changed, we're just going to redraw our path, because the changes to the parent widget might change the size of the clip area. So let's just redraw everything. Okay, not everything actually, but this clip path. Okay, we have this custom clipper. So let's just go ahead and create the embedding widget for these containers. And that guy is going to be a clip path. Okay, so let's go to the left-hand side container. Remember the blue one here? It has to be inside a clip path. So I'm just going to say embed, wrap it with widget, and we say clip path. And it says, okay, it's actually interesting that it doesn't complain that the clipper isn't specified. I mean, you have always a clip path because you want a clipper, okay? And you can see its clipper is a half circle clipper with the left-hand side. And we do the exact same thing for this container. So we say wrap it with widget and we say clip path. And this guy's clipper uses the right-hand side. So what I'm gonna do is I'm gonna change the screen like this and then bring up our simulator and go here. And I'm just gonna press save. And then all of a sudden you see we got that circle shape. All right. So that is pretty much what we wanted from our application. You see, we basically got this down right now. So the shape we got working now. We need to start working on the animations. All right. So what we need to understand is that this animation looks a little bit complicated, and the calculation for this could be a little bit difficult to understand, but is in fact very, very easy. Okay, so what I'm going to do is I'm going to restart this animation. Just have a look at how it starts. One more time. One more time. Blue on the left, yellow on the right, and then it just rotates. It rotates counterclockwise. One more time. I'm just going to keep restarting it so you see the first part. Okay, rotate counterclockwise like this. Okay, that's really good. So I'm just going to keep repeating this. As I said, I usually look at these animations quite a lot of times. And also there is a little bit of a bouncing effect, right? It bounces. So how have we achieved that guy? Well, I'll explain that to you as well, because in the previous example, we looked at animation, but we didn't actually look at curves for animations. All right. And also one more thing, let me just restart the animation a few times. You can see in here that the rotation is happening around which axis? It's the z-axis, right? It is happening with the z-axis that starts from the screen and goes into the screen, okay? So we need to keep that in mind. So what I'm going to do is, or what we're going to do is to turn this guy homepage into a stateful widget first. Okay, so let's just say we turn it into stateful widget, and then we're going to go ahead and create the animation or animations, but we're going to start slow, and we're going to start with the counterclockwise rotation animation. Okay, so this little effect that goes like this. So let's go into the state of our homepage, and I'm going to change this like this so we see the full screen. And let's say we have a late animation controller, and we say it is a counterclockwise rotation controller. So this is our controller. And also we want an animation as well. All right, remember the counterclockwise rotation controller will go from 0 to what? 1. 0 to 1. But every time we rotate this guy, you can see we're rotating by 180 degrees, right? So just let me restart this. You see blue on the left and yellow on the right, and then it's blue on the bottom. So it rotated 180 degrees, right? So like that. You see 180 degrees, not a full circle, because if it was a full circle, it would just go around one more time and the yellow will end up exactly on the side it started. Okay. So for those of you who have a little bit of difficulty imagining how that actually works, I'm going to draw on the screen, and I'm going to delete this note that we have in here. Actually, I decided not to delete. So let's just go here and create a new note. Okay. So here is where we are starting. So this is the blue part like this. Okay. So I'm going to say blue, and we're going to say this is the yellow part like this. In the first part of the animation, if we go and have a look at it, let me just bring it like this, and I'm going to restart the animation. You see yellow ends up on top. Okay, yellow ends up on top. So we're going from this shape on the left-hand side to this shape, yellow on top. So yellow like this and blue like this. And we know that the animation is happening counterclockwise like this. Okay, so if you take this shape right here and you rotate it counterclockwise so that this yellow goes like that and ends up on top counterclockwise, then you're actually rotating 180 degrees, right? Because if you rotate it 45 degrees, so this is 0 degrees, let's say 0 degrees. If you rotate it 45 degrees, then you end up with this shape like this, yellow, right? So I'm just trying to break down this animation for you. So this is 45 degrees, right? And then if you rotate it to 90 degrees, then yellow will be here like this. Okay, yellow and blue. And that's what we're trying to achieve. So when I said earlier that we're going to rotate this guy 180 degrees, that was incorrect. We're going to rotate this guy 90 degrees. Okay, so that is going to be, you can see in here, because this line, if you imagine this line in the middle right here, okay, so first we start with this line, and we're ending up with this line down here. So start and then end. All right. So how does this line go like that and ends up like this? So it's 90 degrees, right? So it's moving 90 degrees. So sorry about that. If I mentioned that it is rotating by half a circle, it's actually rotating by a quarter of an entire circle. So if half a circle, which is this angle in here, which is 180 degrees, and this is half a circle, then we're rotating 90 degrees. So if half a circle is pi, then 90 degrees is pi divided by 2, right? And also, since this, our canvas, you remember when we're working with like counterclockwise movements in Flutter, then we're actually talking about negative angles. So let me bring up the canvas again in Flutter. And this is something that we talked about quite a lot in the previous video. So canvas starts right here. And in trigonometry, canvas starts here. So this is trigonometry and this is Flutter. Okay, so in trigonometry, if we want to go from this point here, start, and we want to end up in here, then we say, okay, we're talking about positive angles. So this is 45 degrees and this is 90 degrees, right? So we go like this. But in Flutter, since the canvas is rotated like this, when we talk about going counterclockwise, then your angles are negative, all right? So you're not actually talking about 45 degrees, you're talking about minus 45, and you're talking about minus 90, or you're basically saying that the angle goes from 0 all the way to minus pi divided by 2, right? Because that minus 90 is minus pi divided by 2, because pi is actually 180 degrees. So 180 degrees divided by 2 minus 90. So we want an animation controller that goes from 0 to 1, and then we want an animation hook to that takes the angle from 0 to what? Minus pi divided by 2. All right, so keep that in mind. That's the animation that we're gonna create in here. And also remember, our animation has to bounce a little bit, right? It is doing this little bouncing thing. So we have to give it a little bit of a curve. But don't worry, we'll talk about that. So let's just create an animation in here. We say an animation of double, and we call it counterclockwise rotation animation. All right. So let's go into init state here. And then we say right after the call to super, we're going to create our counterclockwise rotation controller. So we say in here, counterclockwise counterclockwise rotation controller, and we say it is an animation controller that, let's just say it takes 1 second to do its rotation. And we have to say vsync. I've explained this before in the previous example, so you please watch that previous video if you haven't. And we say with single taker provider state mixin. All right. So this is our animation controller, which takes 1 second. And that means it takes 1 second to do this Z animation, like you're seeing here. Okay. And then now that we have the animation controller, we have to create the animation itself. All right. So we say in here, then we start easy. We say counterclockwise rotation animation is equal to, I'm not going to take the GitHub Copilot suggestion. Let's just create the tween. And we say we start with the angle. We begin. It has 2 parameters, right? Oops, I don't want this. Okay, we say we have a begin. We start at 0 degrees and we have to go to minus pi divided by 2. And remember, pi is in Dart math. So let's say import Dart math, show pi, like this. So I hope that now you're understanding angles a lot easier. All right, a lot of people will look at this and be like, why? Why is it minus? Why is it like pi divided by 2? But we've already explained all of this. So now that we've created the tween, we also need to animate our controller. So let's say we animate our controller so that we get an animation object back, okay? But before this, I want to show you something. You see, whenever it does a Z rotation, it's bouncing. It's like ding, 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 ding. You see, it's as if like you were dropping a coin. All right, so that's when curves come into play. So a curve is, a lot of people also get tripped on this. I'm going to show you what a curve is. It's very easy to explain. I'm going to create a little note in here. So let's say that this is your animation controller. Like I'm going to draw something in here. So let's say that this is an animation controller and that goes, how should I explain this one in here actually? Let's say that an animation controller goes from 0 to 1 like this. All right, so it has a very simple path. It goes like this. All right, it starts with 0, it goes to 1. Now you want to create a curve out of this. So you say, okay, let's just break this guy down. Let's say that this is the 50% sign of 50% mark. This is a 75% mark. So it's 75% complete, and here is 100% complete, that animation controller. Now I want to create a curve that at the 50% mark of the animation controller, it jumps a little bit down and then it goes up, and then it jumps down in here and then it goes up. That's that kind of drop effect that you just saw. And this is a curve. As you can see, it is very simple. It is a curve. You can see it. Okay, so a curved animation, as it's called in Flutter, it takes the current curve or the current progress of this animation controller and it applies a curve to it. And there's so many different types of curves. Like you can find a curve that looks like this. You can find like a curve that goes like this and that comes down and then here and then here. Okay, so there are so many different types of curves. And in this particular example, I think we're gonna create some curve that is called bounce out or something like that, I think. So what bounce out does is that it creates a curve that looks kind of like this. It goes here and it almost goes to the top and then it comes down, it goes almost to the top, comes down, and it goes like this. And also there's really good documentation on the web for Flutter where you can see all these curves visually explained. So I'm not going to tell you exactly where it is. Just go ahead and do some research and find the animation curves in Flutter. They're very well documented. They're all in just one document. So you can see all the curves in just one place. It's very, very exciting to look at. So here, what we're going to do inside this animate, if you see, look at this function, it expects an animation. So what we're going to say, okay, we're going to animate this guy, but we're going to wrap our animation controller within a curve. So let's say a curved animation here, okay? And it says, okay, what is the parent? Well, the parent is our counterclockwise rotation controller. And the curve is going to be from curves object, curves, and we say bounce out, I think. All right, so that's our rotation animation. Okay, we've created that now. So what do we have to do before we actually start using this animation? Well, we go ahead and we say that we have to dispose of our animation controller, this guy, dispose. And also we have to start basically doing our transform. So let's go ahead and say this. What should we do? How should we actually transform this guy? So what we could do is to ensure that this entire row here, as you can see in here, this entire row gets rotated around the z-axis in the center. Okay, so we said the row needs to be inside a transform, okay? And let me bring the iPad again just to explain this part a little bit more. So let me create a new note, and you can see this is our screen, okay? And this is the row that we've created. So let's say that it is here, okay, kind of, and this is like our half circles like this. Now, I mean, it's not perfect drawing, but you get the point. Now, what we want to do is to rotate this entire row around its entire center, okay? Center is right here for the row and also for our half circles as well, okay? So we want to rotate it around the center. So you know what I'm talking about. I'm talking about those, was it the offset of the transform? It was something like alignment, I think it's called. So let's go in here and say the transform has an alignment around the center point, and we say alignment center. And then we say, okay, we want to do a rotation. So we start with a transform parameter in here, and we say matrix 4. So let's just reset matrix 4. We say identity, and we've talked about this in the previous example. And I'm just going to say rotation, rotate Z, like this, okay? And the angle is coming from our counterclockwise rotation animation. It's not coming from the controller, but it's the animation. Remember, the controller goes from 0 to 1. The animation goes from 0 to minus pi divided by 2, which is minus 90 degrees, which is pretty much 90 degrees counterclockwise. Okay, so that's good. We have that, but of course, nothing is going to animate because we don't have an animated builder. All right, so let's go ahead and say this entire transform should be inside an animated builder. So we say animated builder somewhere around here. So let's say a rapid with widget animated builder. And then of course we have to give it an animation, which is our counterclockwise rotation animation. And then we have a builder function as well, remember, in here. And let's just go and remove this child from here and say transform. We get rid of it. Boom, boom. All right, like this. And we place it inside the builder like this. And we say we need to return it as well. All right, like that. Good. So now that we have that, you will start seeing some life into our application soon, because one thing that we've missed is to actually start our animation. So let's go into the build function right here on top, and we say counterclockwise rotation animation controller, sorry, not the animation, but the controller itself. We want to first reset it. Okay, reset means that every time the build function is called, start from 0. Okay, don't start from where you are, because then that might not work if you're already at 1, for instance. Okay, so we say we want to call the forward function in here, but what I want to do is I want to put this guy inside some sort of a future delayed. All right, so what we could do is to say that when the build function gets called, after 1 second, start this thing. So what we could say is say future delayed, and we say the duration is 1 second. Let's say 1 second, and then do this code like this. Boom, boom. All right, so this will be actually fine. You can see in here. Did you see that bounce? And then it stops right there. So let's just see it one more time. I'm gonna resize Visual Studio Code so you see this. I'm gonna restart the application. There we go. After 1 second, there we go. Okay, so it would be really good if you had a little bit of an extension for this guy. So it'd be really good if you could just say forward in 1 second. Okay, so let's just create an extension in here, and we're gonna say extension. Where should we create that? Extension on void callback. And this is to be honest with you, this is pure Flutter, so I'm not gonna explain this so much. All right, so let's just say future void delayed like this, and we say duration is a duration like this, and then let's just create an arrow function in here, and we say then future delayed, and then this. Okay, good. Now that we have that, let's just go ahead and use it. So in here, down there in the build function, let's just take that, and then we say forward, and then we can call forward I would say with just dot delayed. Forward dot delayed. Did it delete the code? No. Extension of void callback delayed. To me, that looks fine, but that's simply because we're calling this function. We shouldn't call this function. This returns void. So we just say it's delayed by duration of 1 second, like this. All right. So you see the code looks a little bit nicer. We say reset and then go forward with a delay of 1 second. All right. So I'm going to bring up our simulator. Let's change the size a little bit like this. And then I'm going to restart the application. Boom. And then if I press Command S, it starts from the beginning, you see, because it resets. So for those of you who don't know why this is there, let me just remove that. And then we just say forward delayed. Let me restart the application from the beginning. You see the first time it works, but then if I press Command S, you see nothing happens. Simply because the animation controller has gone all the way from 0 to 1. It has nowhere further to go from this point. And that's why we had this reset in here. So we say every time the build function is called, reset the animation controller, go from 0, and then go forward. So Command S goes from 0. One more time, goes from 0. All right. So we got that part working now. So there are some optimizations that we could do in here. And this is, I mean, I'm trying to break animations down to one step at a time. But what we need to know is that if you look at the code that we've written in here, this child, which is this row at the moment, really, it doesn't change, right? Like it is a row all the time. There's nothing in this guy that changes. So what you could do is to, because you see we have a child parameter in here, and the point of that is that animated builder also has actually a child parameter that you can create like a child in here, and that child will get passed down here. Okay, but the reason we don't do that, I mean, actually that's kind of like an optimization, but we don't do that right now, but because soon we're going to change these rows change this row as well on all these containers. So hang on tight, because we need to take care of those things. So what happened right now? We took care of that animation, the Z animation, but we now need to flip these guys on top of themselves. So this is the part that this animation gets a little bit complicated. All right, because if you, let me bring up the iPad and look at this animation the way it is happening right now. I'm going to bring up the iPad. Let's see if I can bring up the screen so you see it as well. So what happens if you look at that animation, just the flip animation? So I'm just going to draw the blue half circle in here, okay, and then the yellow half circle. So what we want is simply to flip this circle to this side around the which axis? This is X in Flutter, and this is Y, right? So half a circle, this is a container that we've clipped half of it. So what we're gonna tell Flutter is that, hey, we want to flip this guy, or this entire container basically that contains that guy, around the y-axis in the middle and flip it to this side. And we want to do the same thing but opposite for this guy. So we want to take like this guy on the right here, okay? We want to flip it around this point to the right, to the left. So there is a little bit of a rotation happening in here around the y-axis. Okay, so it's the y-axis. But what happens when our other counterclockwise rotation happens? So let me just create. So you remember that this is our circle. It starts like this. Okay, it starts like this, and then we. So this is blue and yellow, and then we do the counterclockwise CCW animation, and we end up with this shape where the yellow is on top, and then the blue is at the bottom. So what happens in this case? Now we have to, do we have to flip this guy around the x-axis so that yellow comes here and blue goes there? But what happens then when this shape changes one more time and then it rotates counterclockwise again, counterclockwise, and then the yellow ends up here, yellow ends up here, and blue ends up here, and then we want to rotate. Now, all of a sudden, we have to rotate around the y-axis. So it seems like the rotation happens first in the beginning. Actually, do not disturb became off, so I want to set it to on. So let's go in here and say focus is do not disturb everywhere, like this. So let's say that we go in here and say, okay, well, the first time around, the first shape on the left hand side, the rotation is around the y-axis. Okay, then all of a sudden, after we've done one counterclockwise rotation, then all of a sudden we have to rotate around the x-axis. And then again, when another counterclockwise rotation happens of 90 degrees, we have to do what? We have to do, again, the y-axis. So is this really true? Do we have to do this? Or should we just say we always rotate around the y-axis? But how would that work? And this is where some people get tripped up. When you have a canvas like this in Flutter, where this is your x-axis and this is your y-axis, when you flip this with a transform and with a counterclockwise rotation to the left, for instance, basically counterclockwise 90 degrees, all of a sudden this shape will be like that, it comes here, and this will be that comes here. Okay, so your x will be here and then your y will be here. So all of a sudden you flip the canvas. I mean, you're rotating the widget, of course, but you're actually rotating the canvas that holds the widget as well. Okay, it makes complete physical sense and mathematical sense. You're flipping not only the widget, but the canvas that holds the widget. So now that you've done this, now that you flipped the canvas with the first counterclockwise rotation, guess what? Where is the y-axis? It's here. It's not down. It's not going down. It is actually here. It's where the x-axis was. And then if you flip it one more time, then your y-axis becomes where it was before, and your x-axis, where would that go? It will go here. Okay, so I think so, at least. So it's a little bit like at the moment populated on the screen, so I'm kind of like losing track of how I'm drawing things on the screen. But let's create a new note in here. So we say we start like this. So this is x and y. Okay, x and y. Then we say counterclockwise rotation of 90 degrees. Then what happens is that this is 90 degrees in here, right? 90 degrees. Then y goes here. So we say y is all of a sudden here, and x goes there. So x will be, where will that be? So it will be y and then x, right? So this will be our x and this will be our y. Then we say we do another counterclockwise of 90 degrees. Then y goes here. So it will be, if we draw a line like this, y here, and x will go like this. So this will be our y and this will be our x. And then if you do another counterclockwise of 90 degrees, then your y will be like this and your x will be like this. So y and then x. And then of course, another counterclockwise of 90 degrees, counterclockwise of 90 degrees, then your y will go like this. So it will be like this, and your x will be like this. So you've done 90 degrees. So 90 degrees, which is 1, 2, 3, and 4. So if you do 4 90 degrees, you end up with 360 degrees. So you end up here where you started. Fun, right? This is pure just mathematics. So this is how our animation is going to look like. So for those of you who think that we are flipping first around the y-axis, and then we're flipping around the x-axis, I'd have to say no, we're actually only flipping around the y-axis. The difference between this shape in 1 and 2 is that 2 has the entire canvas rotated, so that your x that was here before, that was like this before, xy, has been rotated, so like this. So if you're rotating around this axis, you're actually again rotating around the y-axis, which is how you started here. Okay, so this was a lot of theory, but I just wanted to show you that that part where you see that the animation is happening like here, and then here in the middle, it's only flipping around the y-axis. All right, so let's go ahead now and create our flip animation. And that part is going to be a little bit complicated, but don't worry about it. So let's create first the animation, the controller and the animation for it. So let's say late animation controller, and we say that this is our flip controller, and then we need a flip animation as well. All right. So inside init state, we need to go and create this flip controller. So we just say flip controller like this, boom, boom. And let's go in here and we say flip animation. And we say the flip controller is equal to an animation controller that has a vsync of this and also a duration of 1 second. That's fine as well. But now we're going to get into trouble because you see, we're extending now, or we're actually conforming to to this protocol in here, or our mixin, which is called a single ticker provider state mixin. What a single ticker provider mixin simply means is that it only has capacity to allow one animation controller to sync its vertical sync with this widget. So you can't have two animations, basically, or two animation controllers syncing with the same widget. What you need to do is just to change this guy to a ticker provider state mixin, so not a single one, okay? It's very simple. So we have now the flip controller with the same vsync. What we need to do is to go ahead and create the animation for it as well. Okay, so the animation for this guy, how is that going to work? Let's go back to the canvas in here. If you remember, what we need to do is every time we rotate this guy, around the y-axis, we have to rotate the widget by how much? Do you think is 90 degrees or do you think is 180 degrees? Well, if you're flipping something completely horizontally or vertically around its center, you're flipping it by half a circle. Okay, it's just half a circle. It's 180 degrees. And to be honest with you, this is very difficult to draw on the screen. So it's difficult for me to show this on an iPad screen, but I will actually do my best. Let me see if I can explain this part, how much the flip, how many degrees it is. So let's say that, let me see if I can draw it. So if you have, boom, let me see if I can draw with my pencil. We have this half a circle in here and half a circle in here, okay? And if you think that this guy, this point in here should end up here. So it's a start and this is an end, right? So you have to flip this guy like that, come here. Well, if you look at this, it is half a circle, right? Because if it was a full circle, it would come here and it would go back. So this is 180 degrees flip, and this is 180 degrees flip. So if for this point to come here, it needs to rotate around the y-axis by 180 degrees, and 180 degrees is equal to pi. All right, so our animation, the animation object, should specify a 180 degree angle. So we say flip animation is equal to a tween of double. So it is a value between two values. It goes from 0 to pi, and we also give it a bounce out curve, as we've seen in the previous example. So I accepted this suggestion from GitHub Copilot because it was very easy and it actually had all the values that we want to enter. And I've already explained all of these, okay? So it shouldn't be a surprise for us. Okay, so what we want, now that we have these animations and the animation controller, let's go back to our application. Let's see how we can bring up that simulator, get rid of this. And actually what I'm gonna do is I'm gonna bring this guy up. And what I'm gonna do behind the scenes is to change the animation durations so you see it a little bit slower, okay? So let me bring it up. Look at the animation, what happens? Okay, it bounces out. And then when that bounce out finishes, it rotates around the y-axis, even though it looks like the x-axis, but it's actually the y-axis because the entire canvas is flipped. All right, so let me restart the animation one more time. Boom. You see, first the counterclockwise rotation, and when that ends, we want to start the next animation. So how do we do that? Well, there's something in Flutter called status listener. Okay, so status listener is just a callback on an animation controller, which will tell you when state of the animation changes. All right, so let's go ahead and say, well, we want to listen for when the counterclockwise rotation controller has finished its animation. All right, also before we forget, let's go in here and dispose of our flip controller, pose like this. All right, so let's go ahead and in here and say status listener. And we say when the counterclockwise rotation controller at status listener like this. When it finishes, so we say if status for our counterclockwise rotation is equal to completed like this, then what we want to do is to actually create a new flip animation. All right, so we say the flip animation should again go from 0 to pi. Actually, this one is going to be a little bit different, I think, because so what the flip animation needs to do is ensure that it doesn't always go from 0 to pi. It needs to go from its current value to its current value plus pi. So this is a little bit difficult to explain, but let's just say that you've already done one animation. So let's just restart this. So what is the flip value at the moment? 0 degrees, right? But all of a sudden it goes from 0 to what? 180 degrees. Now, the next time the flip happens after this rotation, we want to go from 180 degrees to 360 degrees. Boom. Okay, so keep 360 degrees now. We do a counterclockwise. And once this finishes, we want to go from 360 degrees to 360 degrees plus 180, right? So this animation needs to be continuous. So whenever the counterclockwise rotation finishes, we need to create a new flip animation. All right, so I'm going to create it and put it in here. And we say it shouldn't go between 0 and pi. It should actually go between flip animations current value to flip animations value plus pi, which is basically the first difference that we create in here. So we always say we want to go pi amount. Okay, in the beginning we go from 0 to pi, but in here we say we go from the current value to pi. So we always increase by pi. All right, and then after that is done, let's see where this ends. Okay, and then we say, and then we reset the flip controller and start the animation. So the flip controller should always go from 0 to 1, and then we reset it, and then we just say forward without any delay. All right, good. So let me restart our application. Let's just have a look at the console. We don't have any errors. And how does our application actually look like? Let's see. Let me just restart. We do the flip. All right, but no one is actually doing any animation for the flipping. So let's go and change that. So what we want to do is to say, I mean, there are different ways of doing this, but I'm not going to do the complicated way. But just know that the way that we're going to handle this right now is not the optimal way. But in the next examples, the more advanced we get, we're going to make this a lot more optimized. Okay, because in this example, we're actually going to use multiple animated builders. We're actually going to use 3 animated builders. Okay, but really to continue to create this effect that we want, you just need 1 animated controller. Animated builder. But just to make things easier for us, I'm just going to use 3. Okay, and I'll explain the reason later in the later examples. So what we want is to say, okay, the clip path in here for the first one, what we want to do is we want to rotate this guy. Okay, so remember, this is the blue side, which is, you can see the blue color in here, which is on the left hand side. So let's say that this clip path wants to be inside an animated builder. So let's say we wrap it with a widget, animated builder, like this. And then we have the child. So let's just remove this and put it in the builder function in here. And we say return this, okay? And it says, okay, what is my animation? All right, we say your animation is the flip controller. All right, so this guy is happy. All right, but it has no animation really at the moment. I mean, it has the animation parameter, but no one is actually transforming this guy, and that's okay. Let's go to the second clip path, which is the half the circle on the right hand side, and we say wrap it with widget, and we say it's an animated builder. We do the same thing. We take the child from here, and then we say we have a builder like this, and we return that child in here like this, and it says, okay, where's my animation? We say your animation is also the flip animation. All right, and then if you run your application right now, it just looks fine, but really nothing happens after that. All right, so what we need to do, our job right now, is to say, okay, apply the transforms around the y-axis. Remember, we need to rotate these guys around the y-axis. So we say the animation is there, but let's go and wrap this clip path inside a transform like this, transform, and we say the alignment now is important. it's very important to understand how the alignment of this animation actually works. So let me bring up the iPad screen again. I actually explained this a little bit earlier, but I'm going to do my best to explain it one more time in here. So let's go and say that we have this row. So this is our row, and these are two containers in here, and this is half the circle here, and this is half the circle in here. So when this guy on the left hand side wants to flip to all the way to the right hand side, it has to flip around the y-axis, right? But around which alignment? Should it flip around the y-axis here? Because remember, this is also the y-axis, this is the y-axis, all of these are y-axis. Where should it flip around? Well, we say it should flip around this point, right? So this entire thing should flip around the center right point. Now, when it comes to this guy, which is, remember, its container is here, okay? This same point that this guy has to flip around on is the center left point, okay? In this container, this point is in the center to the left. But in this container on the left-hand side, this point is in the center right, okay? So remember, center right for the blue one and center left for the yellow one. All right, so let's go to our code. And we say the blue one, the blue container is center right alignment. So we say alignment is alignment center right. And before we forget, we go to this actually we shouldn't maybe do that. Let's just do this one first. And then we say its transform is a matrix 4 identity and rotate around the y-axis with the flip animations value. All right, great. So let's take the same thing and let's just go in here in this clip path, and we say this clip path also needs to be inside a transform. So we say transform, and we say its alignment is center left, remember, right? Center left for the right container, because it has to flip around this point to the left. And then we say its transform is identity rotate y, the same thing basically. So before I start this application, let's go to our simulator here. And then I'm gonna just go here and then restart the entire thing. 1, 2, 3. There we go. Did you see the flip? So one more time, like this, boom, boom. Good. Now, what happened? Why is everything stopping? Well, the reason behind it is that we said that once the first animation finishes, then the second animation has to start. But we never said that the second animation's finish also have to kickstart the first one again. Okay, so let's take care of that. So let's say exactly the same thing that we have up here for add status to the counterclockwise rotation controller. We have to do something like that for the flip controller as well. So let's go in here and say flip controller dot add status listener, and then we say if status is completed. Oops, this is a lot of code. I don't want to accept that because we need to write it ourselves. Okay, boom, boom, add status listener. Good. Do we have extra stuff or no? All right, like this. So we say if the status is completed, then we have to create the animation from scratch. So let's go to, and which animation is it? It is the counterclockwise animation. All right, so let's take the counterclockwise animation that we had here, okay? And you see, we put it in here, but this one as well, it shouldn't go from 0, but it should actually go from its current value. So we say go from your current value and go to your current value again, value, okay, plus that rotation you want to actually do. So it's just a continuous animation, all right? And then we do similar thing that we did up here with the flip controller. We say the counterclockwise controller, counterclockwise rotation controller, you need to reset it first, and then we say forward, okay? And that does the magic for us. Let me just bring up our simulator, which is here, and then I'm gonna reset the entire application like this, 1, 2, 3. Let's see. Oh my God. That's so funny. I think we're actually rotating around the wrong axis. So let's go in here and see what we're doing. So now that we're getting this funky kind of animation in here, it could be a simple explanation that we've somewhere missed the status listeners implementation. So let's go in here and have a look at how we've done the first status listener for the counterclockwise. If status is completed, then we have the code in here. So I usually, what I do, I look at completed and ensure that all the code is inside that completed block. So you can fold it and you can see, yes, it is inside the completed. But if you go in here in completed and fold this code, you can see this call, the reset and forward, is outside the completed call. So let's take this and bring it up here. Okay. And then we can reset our animation and have a look. There we go. There we go. And there. Good. Fantastic. Now we're pretty much basically done with this animation. So let's bring up this animation here, and I'm going to change that guy as well to have 1 second delay for its animation and restart it. So you can pretty much see them side by side. They're doing the exact same thing. All right. So I hope that you enjoyed this video as well. It was very long. It was, you can imagine how I feel right now after all this explanation, and I can totally imagine how you feel after all this explanation. But what I want you to take away from this video is that you need to break animations down. Animations don't just grow on trees, okay? You need to break them down and ensure that you understand the basic blocks of these animations. All right, how they're interacting, like, is there different animation controllers? Are there different animations? And how are they connected to each other? Break it down into a timeline. All right, and then your life will be a lot easier. And also the second part of the mystery is, of course, solving which widgets you have on the screen, how you have to organize these widgets, how they're rotating, how they're animating, etc. Okay, hope you enjoyed this video, and I'll see you in the next one.